away from the sun. Behind them, Lemon is an excellent example. But in our case of 3i Atlas, it looks like a fuzzy ball of light.
Since its identification in mid-2025 as the third interstellar visitor, the comet designated 3I Atlas has been the subject of a coordinated global monitoring campaign. As it moves through the inner solar system, its behavior has prompted new scientific analysis and drawn interest from U.S. lawmakers. The renewed attention on 3I Atlas isn't simply because interstellar objects are rare. It's because this object represents a living laboratory for testing theories about how planetary systems exchange material across the galaxy. NASA scientists are continuing to monitor the comet, even as public communications from the agency are paused, and officials are preparing to brief members of Congress on the current state of observations. Let's get started. On July 1, 2025, the Asteroid Terrestrial Impact Last Alert System, or ATLAS, in Hawaii, flagged a faint object moving at a high velocity. As observatories collected further data, researchers began to model its trajectory. The results indicated the object was not gravitationally bound to our Sun. Its path was determined to be a distinct hyperbola, meaning it entered our solar system from interstellar space and will eventually exit, never to return. An object originating from within our system would follow a closed elliptical orbit. This trajectory confirmed that 3I Atlas was an interstellar visitor, providing a rare opportunity to study material from another star system up close. Its high velocity is consistent with this assessment, confirming it is only passing through. The first interstellar object, 1I Oumuamua, was detected only as it was leaving, allowing for limited data collection. The second, 2I Borisov, behaved much like a typical solar system comet. 3I Atlas presents a different case, and advanced instrumentation has been used to study it. The Hubble Space Telescope constrained the size of its solid nucleus to be no larger than 5.6 kilometers across. More detailed compositional data is emerging from the James Webb Space Telescope. Using infrared spectroscopy, JWST can analyze the chemical makeup of the gas and dust in the comet's coma. Preliminary data hint that the object's composition may evolve as it moves away from the Sun. Spectroscopic measurements indicate that its ice and dust share some similarities with comets from our own Kuiper belt, yet some chemical ratios, particularly involving carbon and nitrogen-bearing compounds, appear distinct. These differences suggest it likely formed in a protoplanetary disk that was different from our own. By modeling its trajectory, researchers can trace its path back to a general region of origin. While the exact star system cannot be pinpointed, these models allow for the possibility that the object originated from older stellar populations in the Milky Way's thick disk. Such an origin could imply a greater age for the object, which has made it a subject of intense scientific inquiry. We'll next examine the scientific and policy response to these findings. For continued analysis of developments in space science, consider subscribing to this channel for future updates. As 3I Atlas passed its closest point to the Sun, astronomers recorded a surge in brightness, suggesting intense outgassing. What caught scientists' attention was the pattern of its acceleration. The object's motion showed small, irregular shifts not fully consistent with models of uniform outgassing. Most researchers attribute this non-gravitational acceleration to asymmetric venting from the nucleus, possibly caused by uneven layering or rotation. Such deviations are not evidence of anything artificial, but they provide valuable insight into how interstellar material behaves under solar radiation. However, a few anomalies persist. Astrophysicist Dr. Avi Loeb and his colleagues argue that the physics behind such motion should be investigated without bias, not because it implies artificial design, but because understanding unexpected forces can expose new natural processes. NASA and the European Space Agency have reiterated that the available data show no evidence of anything other than a natural comet, but they agree that its behavior warrants extended observation. The events surrounding 3I Atlas show how space science and public policy increasingly intersect. Congressional interest in a single comet underscores a new political awareness that discoveries beyond Earth have both scientific and cultural resonance. A briefing was scheduled with Representative Anna Paulina Luna to discuss upcoming data releases and to reassure Congress that monitoring continues. This interest is not focused on speculation, but on long-term strategies for planetary defense and scientific collaboration, as the discovery highlighted that planetary defense models are primarily built for local, not high-velocity interstellar threats. The scientific community is engaged in a race against time, not against each other. As 3I Atlas recedes, it grows fainter, making this the only opportunity to study it with current instruments. What makes this event different is the level of coordination. More than a dozen research institutions are sharing real-time observations through the International Asteroid Warning Network. The campaign involves professional and amateur astronomers alike, aiming to collect data across multiple wavelengths. The goal is to continue tracking 3I Atlas until it becomes too faint to detect, using instruments across both hemispheres to build a continuous timeline. Data will include measurements of its polarization, a property that reveals particle size and structure in the dust cloud, helping scientists estimate how the comet formed. This methodical work is building the most complete data set yet on an interstellar body, with the aim of understanding its density, spin rate, and internal composition before it vanishes back into deep space. The evidence indicates that 3I Atlas is a natural, if unique, interstellar comet. It is not an artificial object, but its scientific importance is profound. It serves as a time capsule, carrying the chemical blueprint of its distant birthplace across the galaxy. This encounter has forced scientists to refine assumptions about cometary behavior and has prompted public policy discussions about our preparedness for interstellar visitors. The broader community is already looking ahead. When the Vera C. Rubin Observatory begins full operations, it will be sensitive enough to detect many more such objects, potentially transforming these fleeting encounters into a new research field, the comparative study of interstellar comets. 3I Atlas is now fading from view, but the data it leaves behind will shape how we study interstellar visitors for years to come. It has connected scientists and lawmakers in a rare global effort of discovery, another reminder that even across light years, our solar system is never truly alone.